Welcome to my channel. This is a computer science channel for engineers, code, concepts, and career. I'm Sushma, and I'm going to take you on a quick, short introduction to my course that I'll be conducting on computer science. So, as a computer science coach, I would like to cover very basic and fundamentals of computer engineering. And my classes are open to people in the secondary, higher secondary education, and also engineering, right from sixth grade computer science, anywhere up to engineering computer science, is what my coaching will be for. So let's begin. How does computer science matter in engineering, right? So any of the software solutions these days are definitely all code based. Coding is telling the machine computer to do what we want it to do in zeros and ones. But since as humans we can't type in zeros and ones, we write a program which will in turn translate into zeros and ones for the computer to understand. And as you all know, some of the most important coding languages today are Python, Java, C++, and whatnot, MATLAB, and so on. Since a lot of real life problems today require software solutions, coding is as important as ever, especially in the era of AI and ML, artificial intelligence and machine learning. It's all the more important, right? So any kind of automation and modeling or even data-driven solutions all rely on code. Even electrical and electronics like IoT devices, internet, uh, devices on the internet, right? All of them require coding solutions in the backend. So, as an engineer, what are the computer science concepts that one needs to know to be able to further their education or job prospects, right? So, these five are the backbones of concepts that a computer science engineer needs to know. First is algorithms and the complexity. Then comes data structures, computer architecture, operating systems, and databases. So, algorithms is the step by step instructions that we give to the computer in the form of a program. And when we write programs, we can write programs that make that are more efficient in terms of time or in terms of storage space for the computer. So, the more we analyze the complexity of the programs, we can write better suited programs for our problem and also for the computer to run fast, optimizing both the storage space it has and also the amount of time that it takes to complete the task. Second is the data structures. So the data that we give to the computer can be stored in multiple formats inside the memory. And the more efficiently we store it, the better the computer will be able to access it. It can access it more quickly in an optimized way, and it can also work on it in the next is data structures. So data structures, as I said, are the way the data is stored in the computer memory, and the more easier and optimized it is, the faster the program can run, right? And it has to be optimized in terms of space and based on the actual utility of the program or the application of the program, whether arrays are better to be used or queues or linked trees or whatever based on that. Similarly, computer architecture is literally what are all the units inside the computer, how is the memory organized, is it primary memory, secondary memory, inside at an even granular level, is the memory going to be organized in terms of bits and how many bits per row and in what format, little endian, big endian. So there's so many concepts in computer architecture. Similarly, we have operating systems and multitasking. So on operating systems, there are varieties of operating systems like Linux, Unix, Microsoft, Windows, and so on. Every operating system has its own pros and cons. Some are more better for security purposes. Some are more graphic purpose oriented. So based on the utility and the context, how can one understand the different operating systems? And the internal structure of the operating system is also very different from OS to OS. So we can discuss that. And then the next is the databases. How is the data organized inside a table with rows and columns, or is it more unstructured data like NoSQL? So this will come under databases. The next is programming languages for engineers. So as we all know today, the topmost programming languages is Python and Java. Python majorly for data science, scripting and automation, Java for all kinds of app development in the front end and also in the back end as JavaScript, right? And C++ more for embedded systems, which is and then MATLAB for simulation and modeling. MATLAB is seen to be used in a lot of research labs.